The diagram above shows the curve with equation y is equal to x minus 4 all squared, where x is a real number, and it intersects a straight line with equation y is equal to 4 at the points A and B. The curve meets the y-axis at point C, and we want to calculate the area of the shaded region bounded by the curve and then the two straight lines AB and BC. So basically this bit here. Okay, so first thing to do is to work out the coordinates of A, B, and C. So we can start off by working out the coordinate of C. If we just expand out the quadratic, so y is equal to x squared minus 8x plus 16. Set x to be 0, and we end up with y is 16. So that is this point here. This is 0, 16. I'll just write that as 16, but the full coordinate is 0, 16. And then for points A and B, we solve the equations of these two things simultaneously. So we replace the y that we have here with 4. That becomes, so the quadratic is as above this, set this equal to 4, rearrange, and then factorize. So two things that times to give 12 and add to give minus 8 are minus 2 and minus 6. So x coordinate for point A is 2, x coordinate for point B is 6, we know the y coordinate is 4. Okay, so the next thing to do is to work out the area of this trapezium. So starting at the origin, going up to point C, down to point B, down to the x-axis, and then across back to the origin. So that whole trapezium. Area of a trapezium is equal to a half a plus b times h. So the a and the b in this case would be these two lengths, this one and this one. This is 16. This here would be 4. And the height of our trapezium would be this length, which is 6. So it'll be a half a plus b, which is 16 plus 4, multiplied by the height, which is 6. So that ends up being 60. So the area of this whole trapezium is 60. The next thing to do is to work out what this area here is, the rectangle. So the area of the rectangle, that's pretty straightforward. You would just do this length, which is 4, 6 minus 2 is 4, and this length here, which is also 4, times them together, and we get 16. And then finally, we work out what this area underneath the curve is. So underneath the curve, so between the curve and the x-axis. And to do that, we would integrate. So we integrate the equation of the curve, which was x squared minus 8x plus 16. Integrate that between 0 and 2. So that is x cubed over 3 minus 4x squared plus 16x. Limits 2 and 0. This is then 8 over 3 minus 16 plus 32, which when you type this in your calculator gives you 56 over 3. So that's the area underneath the curve, which I'll call AC. That is 56 over 3. Okay, so let's just go back up to the graph. So now we put all these areas together. We have the area of the trapezium, so that minus the area of this rectangle, and then subtract the area underneath the curve here, and that will give us the shaded region that we want to work out. So that would be area of trapezium minus the area of that rectangle beneath, and minus the area of the curve beneath, to get the leftover shaded region. And this gives us 76 over 3, which is our final answer.